So we're going to be finishing off the second part of lesson 4. Remember what we did yesterday? So we learned about discontinuities. Actually, we started discontinuities with non-permissible values. What a discontinuity is, if a rational function has an NPV. So if the denominator gives you an NPV, the graph of that function is not going to be a continuous curve. It's going to be discontinuous. There are two types of discontinuities that you need to know about. The two different types were what you did in 20-1 and the first couple lessons in 30-1, and that was NPVs. The second type is what you were introduced to yesterday, and that was holes in your graph. Now, holes, sometimes the test will say holes, or holes are also referred to as points of discontinuity. So it's just right here. If you see a question that says, what are the points of discontinuity? They're asking you, what are the holes in the graph? So NPVs, you have to remember, when numerator and denominator is factored, there are no common factors. Holes in your graph come from common factors. So let's look at an example. We'll do a second example on page 468. So the next page, we'll do another example. And again, we're going to change this. I'm not going to give you a third degree polynomial to factor. We did that in polynomials. So let's change this and let's factor this. So let's look at this rational function. F of x is equal to x minus 4 all over x squared minus 5x plus 4. First thing you do is you make sure numerator and denominator are factored. If they could be factored, you factor them, and they will be able to be factored. So we've got to factor that denominator. So f of x is equal to, I'm going to put that x minus 4 in a bracket because that's a factor. And then in the denominator, we're looking for the two numbers that sum to 4 and add to negative 5. So what would they be? Negative 1 and negative 4. Yep. X minus 1 and x minus 4. Once you have your two factors, highlight if any of them are common. So before I do anything after this, I get my highlighter out and I just highlight what's common. So this guy's common. Okay, then you have to state what the non-permissible values are. So we've got two non-permissible values in this graph. So this guy here, so I'll just write NPVs. X could not be equal to 1, right? That's a non-permissible value. Once you tell me what the non-permissible value is, you have to then say, was that the hole or is that a VA in your graph? So what would this give you? It is not a common factor. There's no x minus 1 up here. What would this give you? This is going to give you a VA in your graph. If there's no common factor, this will be the VA, and this guy's going to be the hole. So this graph is going to have one of each. So x cannot be equal to 1. Therefore, there's going to be a VA at x is equal to 1. Okay, so that's one of my discontinuities, is a vertical asymptote. Then, after I do that, I'm going to take care of the hole. So this is another non-permissible value, right? X could not be equal to 4. That, though, is not a VA. That's a hole in my graph. So there's a hole, or a point of discontinuity, at x is equal to 4. And then we have to find the y value. So x is equal to 4, and we got to find the y value of the hole. So we need to know what y cannot be equal to. How you get that is you need to simplify this rational function. So after you've got all of the NPVs out, you've told me if they're VAs or if they're holes, you then simplify. So if it's got a hole, you're going to have fractions that will cancel. So we're going to have f of x is equal to 1 over x minus 1. From here, we need to figure out the y value of the whole. So the y value of the whole is once you have your simplified rational function, you take that x and you put it in that function. So we're going to take that 4, that was the y value of the whole, and we're going to put that in for x. So I'm going to have a 4 here and a 4 here. F of 4 is equal to 1 over 3. So the y value of the whole is 1/3. Students, when they do their range, they always forget the y value of the whole. So as soon as I see this, I then just make a note what y cannot be equal to. So y cannot be equal to 1/3. Okay. We've got what x cannot be equal to. X can't be these two when we're doing our domain. Y cannot be equal to 1/3. Now, let's after I figure out all the discontinuities, let's do the degree of the graph. Like, what is the horizontal asymptote going to be? So look at your degree of numerator and degree of denominator. So this guy is a degree 1, and this is a second degree. So you're going to write degree of n of x is less than degree of d of x. So my 2 there. Therefore, do you remember what it would be of the 3 cases? Yeah. Therefore, there's a horizontal asymptote at y is equal to 0. So I had a vertical asymptote, I had a horizontal asymptote, I have a whole. Let's see if you could do the domain and range. So write what you think it would be. Remember, you always have to say what x cannot be first, or what y cannot be. So x could not be equal to 1, that was the VA, or 4, that was the HA. But other than that, x would belong to the set of real numbers. The range is y is such that y cannot be equal to 0. So students will always remember this for the range. It's this guy that they'll forget. They'll forget the 1/3. And then YER. One other thing I want you to note is they might say to you, what is the equation of the new rational function? And what the equation of the new rational function would be, it would be the equation after we've canceled our common factors. So the equation of the new rational function would be f of x is equal to 1 over x minus 1. That was the equation. But then what you have to do is you have to say comma when you're writing the equation, and you have to tell me what x cannot be. So x cannot be 1, which we already can see from here, but it could also not be 4 from the original. So you have to put the 1 and you've got to put the 4. And that would be the equation. If you were ever to graph this, you don't ever graph the new function. You always graph the original, okay? Because you won't see the VAs and the wholes if you just graph this new function. You need to see it from the original. Okay, that's pretty much the lesson. Let's look at what this would look like on a diploma question. So there's 2 diploma questions. And we'll start out with this guy. So 14. They even factored it, right? So you see this. First thing you do is you take your highlighter, highlight if something is common. Because if something is common, that's your point of discontinuity, and that's going to give you the whole. So this and this. And then jot it down, right? This, what we just highlighted, that is going to be your whole on your graph. Or in brackets, point of discontinuity. This would be the VA. If it's not a common factor, that's the VA. So that's going to be the VA for my graph. How do you get the VA? You find that non-permissible value. So negative x plus 1 cannot be equal to 0. Solve for x. So there's going to be a vertical asymptote, or sorry, x could not be equal to negative 1. Therefore, there's a VA at x is equal to 1. So we know that it's either going to be B or D. Then we've got to do the horizontal asymptote. So it's already factored, so you have to sort of think, what would the degree of this function be? Do you know what the degree of each would be? Like, what's the degree of this top? If you were to expand this, what's your highest power of x? 2. Yeah, because if you do 3x times 2x, you'd have 6x squared. So up top, we would have a second degree polynomial. So that's a degree 2. In the denominator, we would have, what would that be if you were to expand this? It would be a degree 2 as well, yes, because negative x times 3x would be negative 3x squared. So that guy's a degree 2. The degree of n of x is equal to the degree of d of x. Therefore, what was this one? Yeah, this was the one. This is sort of the one that I memorize. This is the one that will give you when they're equal, y is equal to a over b. So there's going to be a horizontal asymptote at y is equal to a over b. A is the leading coefficient of the numerator. B is the leading coefficient of the denominator. So if I were to expand this and then write it in descending order of x, I don't even have to do the entire thing, but um, the leading coefficient here, or the first term, would be 6x squared. Right? I'm not even going to expand the rest because I know that that would be my leading coefficient. And then for the denominator here, negative x times 3x is going to give you negative 3x squared. Right? So now you should know what your leading coefficients are. So there's going to be a horizontal asymptote at 6 over negative 3, which is y is equal to negative 2. So that leaves D as our solution. So easy questions. If you know which is the VA, which is the whole, and you've got to memorize those 3 cases for horizontal asymptotes. Let's look at this last one. So we got a bit more work because we have to factor that numerator, and it's going to be factoring by decomposition. So let's get this factored because I actually don't have it done. So you're looking for what multiplies or gives a product, 2 numbers that give a product of negative 12 and a sum of negative 11. What would it be? Negative what? Negative 12 and 1. Yes. Okay, so I'm going to just rewrite this. 3x squared minus 11x minus 4. Decomposition, you break that middle term. How do you get negative 11x's based on this answer? Negative 12x plus 1x. and then bring down that negative 4, bring down that 3x squared. Split it in half and group factor. I could factor out from those two terms a 3x. And then on the right-hand side, I could factor out a plus 1. So my answer would have been 3x plus 1 and x minus 4. Like that's the most amount of work you'd have to do for these type of questions. Okay, let's rewrite our rational function in factored form. So the numerator we said would be 3x plus 1. Denominator x minus 4. Sorry, those are the two factors in the numerator. Denominator is x minus 4 and x plus 4. Without even reading the question, I highlight. If I could highlight, I highlight. So I would be highlighting the common factor. And then I always make note that that's the whole. Whole at x is equal to 4. This would be what? That's the VA. VA at x is equal to negative 4. Now we can go and read the question. It says the graph of this function has a point of discontinuity. So here's how they would say it, right? You just have to know that that point of discontinuity, that is your whole. That's what they want to talk about. And this is the point of discontinuity. I know what m is. Graham, what's m going to be? 4. I just have to figure out what n is. And the question is, what is the value of n? So in order to do that, see if you could figure it out. Finish off this. Simplify your rational function. Once you have it simplified, you take your x's out and you put in the x value of the whole, which is going to be 4. So I'm going to put a 4 here, 4 here, and a 4 here. Oh. So 13 over 8. Is that what you guys are getting? Okay, so that's my n value, and it was D. Would have been your answer. Here's what I want you to do for the homework for that lesson 4. There's only 3 questions. So for lesson 4, I want you to do questions 1, 2, and 6. Number 2, I have starred. So let's just quickly look at number 2. Not starred because I would write a question in this way, but just starred because you have to rewrite this question. What's wrong, first of all, with the way the numerator is written? Yeah, it's not in descending order of x. So let's rewrite this first of all in descending order of x. And sorry, it's a g of x function, not an f of x. Then it's still not correct because you can't factor unless we have an a value of 1. Right now the a value is negative 1. So you need to factor out from this numerator a negative 1. So what that would then give you would be g of x is equal to negative, and you would have x squared plus 2x minus 15. And you could have x plus 5. And then you're going to be looking for the two numbers that multiply to 15 and sum to 3. Or sorry, sum to 2. So it's going to be 5 and 3. So finish off those. I'll give you about 10 minutes and then we'll do the next lesson.